Hello everyone. I hope that you are doing well. Let's start our class today and we'll keep talking about soil classification. In our last class, we talked about the jelly soils, those soils that possess a very low temperature. Okay, they possess permafrost, and the presence of permafrost and or materials that evidence the cryoturbation, the gel-like materials, they give us the soil order, or they could help us to classify soil as jelly soils. Today, we will talk about the histosols and spodosols. The histosols are those soils that cannot be classified as jelly soils. So the first step, the first criteria, the first thing that you need to know is that to be classified as a histosol, a specific and physical soil profile cannot follow all the criteria to be classified as a jelly soil. Okay, so first of all is that this physical soil profile cannot be classified as a jelly soil. Okay, and the histosols, they also did not present any index soil property in at least 60% or more of the thickness in a horizon between the surface and 16 centimeters, okay, or between the surface of the soil and the density, lithic, parallelithic contact, or the ripen, or we can think in any kind of material that could avoid or mark a zone that we have very low weathering. Okay, so between the surface and the first 6 centimeters, or between the surface and this contact, we cannot find any abundance of endic soil property. So we cannot find a lot of elephant, immogolite, and high content of aluminium and iron that are related to glass minerals, to rock that express modern or recent volcanism. Okay, so to be classified as a histosol, we cannot find a lot of these specific parent materials and minerals in the soils. Okay, beyond of that, to be classified as a histosol, these soils should present a high content of organic carbon, so they should present organic soil materials, and the organic soil materials, they should follow one or more of these criteria. Okay, so if this organic material, they overlies any ash or pumiceous materials formed by modern volcanism, they could overlay this material, and directly below we should find a densic, lithic, or parallel contact. So we need find below this organic material with ash, we need to find a horizon or layer that express very low weathering. Okay, if we found the opposite, when we found something like this organic matter that was buried by ash or pumiceous materials, we should find that this soil should possess at least 50 centimeters, and between this 50 centimeters, at least 40 centimeters should compose the organic soil materials, or should be composed by organic soil materials. So in the first 50 centimeters, we should find at least 40 centimeters of organic soil materials. These organic materials also should possess a thickness. Okay, so if these organic materials, if they cover a densic, a lithic, or a paralithic contact, so layers and horizons which express an incipient weathering, if I can find these organic materials covering these horizons and layers, these organic materials should comprise at least 2/3 of the total thickness of the soil. Okay, and in this case, the mineral horizons should be absent, or they should comprise a total thickness of 10 centimeters or less. So if I can find organic materials over a lithic, paralithic, or densic contact, so at least 2/3 of the total soil, of the thickness of the soil, should comprise or should be comprised by organic materials. Okay, another option to classify an histosol is that we have a soil that in the first 40 centimeters from the top of the soil, from the surface of the soil, we have flooded conditions for at least 30 days, okay, or 30 normal years in normal conditions, or we had a flooded soil, but it was artificially drained by human activity. Okay, and in these flooded conditions, we have a horizon with organic materials which thickness is 6 centimeters or more. If at least 3/4 of the total volume of this organic horizon, it's composed essentially by moss fibers, or bulk, or present a bulk density lower than 0.1 grams per cubic centimeter. Okay, so if we found a lot of fibers, we should possess a very thick horizon. Okay, but if we cannot find a lot of fibers, if this organic horizon or layer is composed essentially by separate or amic materials, organic materials that already had decomposed, at least partially decomposed, okay, or we have fabric materials, but they present a low quantity, or they present a high density. So this horizon with flooded conditions should possess at least 40 centimeters. Okay, so again, if we have flooded conditions, these organic materials, they should be found in the first 40 centimeters, and the thickness of these organic horizons or layers could be 60 centimeters or 40 centimeters according to the composition of these organic materials. These histosols, as we know, they are composed by one specific apaton. Okay, so we need to check here in this case the histic or pholistic apatons, those organic apatons which express a high content of organic matter, so intense accumulation of organic materials due fluid conditions or cold conditions. We can see some examples of these histosols in these areas. One, for example, very thin layer, and we can find below the R layer, but the thickness of this specific organic material, it's enough to be classified as a histosol, because even this very thin horizons, if they overlie R layer, lithic contact in this specific case, they could possess a very thin thickness. The other soil order that we need to talk about is the spodosols. The spodosols, they are soils that present spodic horizons, okay? These spodic horizons, as we know, they express clay illuviation, clay migration, but essentially organic materials. Okay, so they express migration of organic matter from the surface, from the A horizon or the E horizon, and these materials concentrate in a specific B horizon. This specific B horizon could follow all the criteria to be classified as a spodic horizon and eventually also classified as spodosols. In this case, we know that we have alluvial iron and aluminum oxides, and we also present soil organic matter accumulation by alluvial process, by translocation process, by the process that we call podzolization. These pictures, they present us the spodosols, so we can easily see here close to the surface the A horizon, and in this picture on the left we can see a very thick E horizon with the stones, okay, and below we can see in this yellow color the spodic horizon, and this soil follow all the criteria to be classified as a spodosol. The same from the soil profile on the right, that we can see in this case not a yellow but a dark color that express clay migration, that express the concentration of organic matter in the subsurface horizon. The criteria to classify a spodosol, they are that for this specific soil we cannot find a Pelagian, a pattern, or an argillic or candic horizon over this spodic horizon. So between the surface and the spodic horizon, we should not find an argillic or candic horizon, and we cannot find a Pelagian apatum. Okay, why? Because the argillic and candic horizon in this specific cases, they will help us to identify and classify other soil orders. Okay, so if I found an argillic horizon and below this argillic horizon I found a spodic horizon, this is not a spodosol but could be, for example, an alphysol, other soil order that we want to know. We will talk about this in the next classes. Of course, the same for the candic horizon. If we found between the surface and the spodic horizon, candic horizon, this soil order could be classified as a ultusol, for example. And we also cannot find a Pelagian apatum, and this Pelagian apatum cannot be found because it express in this specific case that we can found some clay migration, some organic matter migration, but in this case is not the same process that express the puzzleization. So it's not the same process that could create a true spodic horizon. Okay, so to identify an spodosol, first of all, we need to know that I cannot found argillic or candic horizons, and I also cannot found a Pelagian apatum. Okay, this two, the argillic or candic, of course, I cannot found between the surface and the spodic horizon. If I found a candic or argillic horizons below the spodic horizon, it's not a problem. We can found some soils like that, and in this case, I can classify the soil as a spodosol. It's not a real problem, okay? We also need to know that the spodosols, they should present, of course, the spodic horizon, okay? And they also should present albic horizon in 50% or more in a specific soil profile and acrylic or gelic soil temperature regimes, okay? We didn't talk about this soil temperature regimes because we don't have so much time, but the cryotic soil temperature regime express an average temperature below 0 Celsius degree. So in some very cold regions, we can find that these soils present temperatures in an average around a specific year. So an annual average soil temperature should be equal or below 0 Celsius degree. Okay, the gelic soil temperature, it's a warmer soil temperature regime that the average of the soil temperatures varies between 0 and 8 Celsius degree. So in this specific case, I have warmer temperatures, and in this specific condition, we also cannot find permafrost. So we can find the permafrost and the cryotic soil regime, but we cannot find permafrost and the gelic soil temperature regime. Okay? We also can find an AP horizon with at least 85% or more of spodic materials. So we can find any kind of evidence of human mixing of the soil. And in this case, we need to find an abundance of a high percentage of spodic materials, materials which express organic matter migration from the surface to subsurface horizon. To the spodic horizon, this spodic horizon also should follow some specific characteristics, okay? As we already know, on a specific soil order is not the same to a specific soil diagnostic horizon. So the spodosols, they are a specific thing, and the spodic horizon is another thing. Okay, so to classify spodosol, I need a spodic horizon, but this specific spodic horizon also should has a thickness of 10 centimeters or more. So if you remind to identify spodic horizon, we can find some spodic horizons that could be very thin, something like 2.5 centimeters of thickness. But to classify an spodosol, this spodic horizon should be thicker, okay? Also, this specific spodic horizon could be overlaid by an AP horizon, or this spodic horizon could present cementation in at least 50% or more, okay? Or this spodic horizon could present a sandy or loamy texture and a frigid temperature soil regime. Okay, what is this frigid temperature soil regime? The frigid, it's a little warmer than the Craic, okay. This case we have warmer temperatures in the summer, and the difference of the temperature between the summer and the winter, it's equal or higher than 16 Celsius degree. So we have a high variation of temperature between the winter and summer in this specific soil regime, soil temperature regime, okay? Or we can have any texture, not necessarily a sandy or a loamy texture, and found on spodic horizon with a cryic or a gelic soil temperature regime. Again, the cryic is that soil regime that we found temperatures that varies between 0 and 8 Celsius degree, and I cannot find the permafrost. And the gelic are those soils that possess annual an average annual temperature equal or below 0 Celsius degree. We also should find that the top of this spodic horizon should be found in the first 50 centimeters below the surface, okay, or in the first 200 centimeters if this spodic horizon possess a sandy or a loamy texture, okay, and the materials between these horizons also present this kind of texture, and the bottom, the end of this spodic horizon should possess at least 25 centimeters below the surface, or the bottom of the spodic horizon should be over a duripan, a fragipan, or a dansic, lithic, paralithic, or petroferric contact. So the bottom position of the spodec horizon should be followed by the top of a cemented horizon or a layer that express the parent material of this specific soil. Okay, the specific spodec horizon also can end in any depth if they present a sandy or loamy texture and present frigid soil temperature regime, okay? Or if this specific soil, spodec horizon possess a cryonic or a gelic soil temperature regime. The spodec horizon also should be covered by an albic horizon, okay, by a thick albic horizon, and this albic horizon should comprise at least 50% of the total area of the soil profile. So one option to classify the spodosols is to find a thick albic horizon which covers the spodec horizon. Okay. Another option is to not register index soil properties in a high amount of the soil profile. Okay, the index soil properties are those properties that express recent or modern volcanism because they express presence of allophane, immogolite, and other low crystallinity minerals. Okay, these index soil properties, they also express a huge chemical link between soil organic matter, aluminum, and iron. It's why we are talking that the spodosols, they could not present these index soil properties because we have strong link between iron, aluminum, and soil organic matter in the spodosols. But this strong link is related not to low crystallinity minerals, but by the alluvial material that concentrate these bodies, these chemicals in the B horizon. Okay, so spodosols, they should possess less than 60% of index soil properties, and this little presence or absence of index soil properties, they should be present in a specific thickness of the soil, and this specific thickness changes according to the material below the spodec horizon. Okay, if we don't have any densic, lithic, or paralithic contact, Duripan or petrocalcic horizon, any layer or horizon that express low weathering or cementation, okay, in these cases we need to find that the first 6 centimeters from the mineral soil surface or the top of the organic layer with index soil properties, in this specific thickness, we cannot find a huge amount of index soil properties, or they express just a little quantity of the soil. So in the first 6 centimeters, if we cannot find any R layer, for example, like the lithic or paralithic contact, or cannot find anything cemented like a duripan or a petrocalcic horizon. Okay, but if we have these horizons and layers that express cementation or very low weathering, we cannot find index soil properties between the soil surface and these layers or horizons. So we cannot find index soil properties in 6% or more of the thickness of horizons and layers between the mineral soil surface or the top of the organic layer with index soil properties and the top of the densec contact, the lithic contact or the paraleft contact, the duripan or a petrocalcic horizon. Okay, so are two options according which materials compose the bottom part, the bottom layers, the bottom horizons of this specific soil profile. Okay, so what we need to memorize is that the spodosols, they are soils composed by alluvial organic material, aluminum and iron oxides. They could not present endic soil properties and they express alluviation, podsolization, migration of organic matter. Okay. On the other hand, the histosols, they possess a huge amount of organic matter that could be related to flooded or non-flooded conditions. Okay,